Hello, everyone. I thought I would pop in and just help with some stuff on vectors. So I kind of pulled up a lesson that I've used in the past here to just show you a couple things. What I have on my screen right now is stuff that you've all been doing really well with. So component form of a vector, just a couple things to point out here that in order to find component form, if you have the initial point and the terminal point, is that you are going to take terminal minus initial. Okay. So you're always doing x2 minus x1, y2 minus y1 in order to figure out what this would look like in component form. One thing that you've probably noticed from some of the videos that we've posted is that when we do vector form, I always do what I call pointy parentheses to denote that we have a vector. The videos that I've seen don't always do it that way. So just be aware of that. We've got magnitude formula here, which hopefully you have that written down. If not, now is your opportunity. We've gone through a little bit of linear combination form where we use these standard unit vectors I and j to represent what's happening in the x direction, what's happening in the y direction. So in component form, the vector negative 2, 3 would just look like negative 2i plus 3j. So again, these are all things you've been doing really well with. No worries there. Okay, just thought I'd give you an extra opportunity if you wanted to write any of that stuff down. Now, one of the things that I wanted to point out, your vector operations. Now, sketching them geometrically doesn't seem like it's a problem at all. Okay, but combining some of these operations together, I did notice some people were struggling with a little bit. So basically what we would do is if we see an operation like 3 times v, obviously we're just taking v, we're multiplying both x component and y component by 3. So that should be negative 12 and 6. Oh gosh, I can't. So usually when I write, it's not like just hanging out in the air like this. So it's going to look not so nice. Sorry. U plus V, you've seen, you just add the X components, you add the Y components. Not a problem. Okay. But let's go over this. Yep, this would have been a warm-up problem. If I am combining, so let's say like part C right here, I'm combining those operations. So I'm taking V, which is negative 2, 5, and I'm adding the result of multiplying W by 2. So I would do my order of operations. I would first multiply W by 2 and get the vector 6, 8. And then I'm adding negative 2, 5 to that. So I should be getting the resultant 4, 13. Okay, so like anything else, it's just about doing your order of operations and following the directions that you're given when combining addition with multiplication or anything like that. Okay, now those ones kind of light problems. The one that I know some people were having a tough time with was direction angle. Direction angle, you really have to pay attention to the quadrant. So whenever we want to find a direction angle, we are always using the formula. And I think you'll see it as tangent of theta, is equal to A over B. Now, A and B are just ways to notate our vector. Really, the idea that you have to keep in mind is when we studied the unit circle, we already said tangent of theta is equal to y over x. So if you just think about that, we are taking the y component of our vector over the x component, and we're finding the inverse tangent of them. So the inverse tangent of the y component over the x component. That's it. But we do have to pay attention to the quadrant that we're in, because whenever we do this operation where we do the inverse tangent, remember arctan, you're always going to get something in quadrant 1 or quadrant 4, if you remember that from a couple of units ago. I know it's been a while. But if we take a look at, some of the other problems that you've done on Delta Math, we're not always in quadrant 1 or 4. We could be in 2 or 3. Okay, so something to keep in mind, this theta that you're getting right here is really just a reference angle. Reference angle tells you how far away you are from the x-axis. So if I'm in quadrant 1, then my reference angles are all going to be between 0 and 90, and quadrant 1, all my angles are between 0 and 90. So that's pretty great. So like if we're doing this one right here for part A, whatever you find when you do the inverse tangent will be the direction angle. If we're doing a problem like B here though, 3, -4, positive, negative will be down here in quadrant 4. So when I go ahead and I take the inverse tangent of my y component over my x component, you notice too, if you plug in a negative, you're actually going to get a negative angle in your calculator because that's your quadrant 4 when you do arctan. So if I take the inverse tangent of -4/3, I'm getting -53.13 degrees. However, we typically want positive angles between 0 and 360. So this is my reference. It's telling me I'm 53 degrees away from the x-axis here. Well, what is the angle measure of my x-axis on this side? It's 360 degrees. So really, it's this angle that is 53.13 degrees. And the way I figure out what the angle the angle that would be going right here, my theta angle, would be 360 minus 53.13, which I got 306.87. So if I'm solving for theta for part B here, I would do 306.87, or pay attention to what it says in delta math. If it wants the nearest degree, do 307 degrees. Okay, now let's say for a quick example, I'm actually over here in quadrant 2. And I guess just for fun, let's make this vector -3, 4. So we'll just change the sign. Probably should do pointy parentheses. We'll just change the signs of part B there, okay? If I change this and I make this -3, 4, guess what? I'm still going to get 53.13 right here. But how do I figure out what my angle is over here in quadrant 2? Well, again, 53.13 is my reference angle. So it's this angle right here that's telling me I'm 53.13 degrees away from the x-axis. Well, what's the measure of the x-axis over here? It's 180. So since I'm going backwards, back into quadrant 2, I have to take 180 minus 53.13, which tells me that this angle right here, this theta, would be equal to 126.87. Okay, what would I do if I was in quadrant 3? Oh, maybe I need a different color here. If I was in quadrant 3 over here, then this angle would be 53.13. And now I'm moving ahead into quadrant 3, so I'm going to take 180 plus 53.13. And I would get that whole angle, 233.13. And I've done a lot of terrible chicken scratch handwriting on here, but I hope that that makes a little more sense into how you take this direction angle and you place your vector in any quadrant that is appropriate given your ordered pair here. And if you have any more questions, you just let me know. And I miss all your faces. And I hope you have a wonderful day. We'll talk to you soon is my hope. Okay.